I'm trying to imagine you all sitting at the Delhi Fire Hall, and we're just having a nice chat. And as somebody mentioned in the chat box, the only thing to be missing is Barb's lunch. So maybe I will, after lunch, I'll share a picture of the piece of pie I'm going to eat for lunch. But anyway, to get started, our first cut is something that we did last spring, and we had this question. It seems like we got this question fairly often of when is it too late to apply nitrogen fertilizer to first cutting grass field? Especially last spring, it was very wet. People were concerned about how am I going to get the fertilizer on these fields when everything's wet? How long can I wait? It's okay. So here's what we did. There is this year tall fescue field on the flats just outside of Walton, so it was easy for us to access from our office. And a nice thick stand of tall fescue. We applied 100 pounds per acre of nitrogen as ammonium sulfate. So that's the high end of our recommendation. We recommend 75 to 100 pounds of nitrogen per acre on grass hay fields at green up in the spring. So we started, we put nitrogen out on these 5 dates, starting on the 11th of April, and then once a week through the 9th of May. We had 6x6 plots, 6 foot by 6 foot plots that we applied this nitrogen by hand, and we replicated it 4 times. So that takes out the variability of, well, what's just happening in this little space. So with replications, that gives us a chance to have more confidence in the results. So we said we start at green up. So what is green up, or when is green up? And green up certainly is a different time every year. So I went out yesterday. Here's a picture from yesterday on a grass hay field here in Walton, and the green is starting to come through. And so I would say, when is green up in 2020? It's today. It's right now. Probably any time from now forward would be okay for applying nitrogen. But how long can you go? Results starting from the 11th of April. Again, our cutting dates, I didn't mention that before, but our cutting date was May 20th for first cutting. So when we put nitrogen on 11th of April, we had 1.5 tons of dry matter per acre, where we applied on the very earliest date, which, again, remember last spring got a little later start. This was pretty close to what we would call green up. Maybe we were half a week later than what you might call green up. Our control, where we put no nitrogen on, was only 0.8 of a ton. You can see that the 18th of April, the 25th of April, the 2nd of May were all very similar, just a little bit less than the earliest, but still an impressive and very profitable response to that nitrogen. When we waited till the May 9th, so it was only 10 days before we made the first harvest, we didn't get any response to nitrogen. There was not enough time for those plants to respond and start to grow more So we had, somewhere in that after the first week of May, it's probably too late to get any response in first cutting. But certainly in this first week of May, even though that seems late, even though if you are applying with a tractor and a nitrogen cart, you'd be making probably tracks that would show up for the rest of the cutting. It was definitely worthwhile doing. What we noticed is that on these plots that we've applied nitrogen on late, when we went back and look at the second cutting regrowth, we could see that these were greener than places where we hadn't, or that had nitrogen earlier. So we looked at a second cutting. We took the second cutting on July 8th. Again, maybe a hair late, but you can see that on those plots where we put the nitrogen late on first cutting, we had a carryover effect into second cutting. So, maybe that nitrogen wasn't completely wasted in that it gave us a response in second cutting. But you can see certainly there was no nitrogen left over in these earlier cut plots to give a response in second cutting. So maybe one of the things we learned is that, again, this was a field that really didn't have much manure because we were looking for that kind of situation, so we didn't have the complications of what the manure nitrogen contribution might be. But probably certainly for encouraging more yield in second cutting, a second application of nitrogen would be smart. And then you can see in the control, we definitely had very little yield where we didn't have any nitrogen for the season. So here's what the yields looks like when you add first cutting onto second cutting. You can see that all of these April and first week of May plots were just about the same in yield. We definitely lost a little bit maybe in the 9th of May, and then again, like shouldn't be surprising, with no nitrogen, we had not a very good yield. So what about quality? The first item of quality that we think is most important is nutrient-detergent fiber. How much fiber is in that forage? Again, our target for fiber quality is 50% NDF in grass hay. And you can see the blue bars are first cutting. Basically, we hit that right on the nose with our May 20th cutting date. And not a lot of variation in the fiber quality. Second cutting, again, on the average, we came up with a pretty good, pretty respectable NDF content. And you can see maybe the places where there was a little more growth, where the plants had been stimulated to be a little larger, that there's a little more fiber. I think mostly because those plants are bigger. They have to hold themselves up. They have to have a little bit more fiber. But certainly all of those are within our target for what we would like to see. UNDF 240, this is the undigestible fiber in the plants. You can see there's not a lot of difference here. We would generally expect it to be higher in second cutting than first cutting. And you can see these two second cuttings where they were a little larger, had a little more response. There was a little more indigestible fiber, again, because those plants were bigger, they were holding themselves up. There's a little more structural fiber there. Fiber digestibility, or NDFD, again, is another important factor in forage quality and how much energy that our cows can get out of those forages. And you can see our first cuttings were just about right at 70% NDFD. Again, excellent quality forage. And our second cutting was only a bit lower. So those cutting dates, I think we hit our quality windows reliably. And then crude protein. Again, this should not be a surprise. A main component of protein is nitrogen. And so where we have some more nitrogen, we have higher proteins. And you can see our first cuttings were all in the 20s, which is definitely higher than we need for good quality forage, but it's certainly something that we can use in our rations. Second cuttings were down in the 16 range, but definitely very usable quality for what we're looking for our cow rations. It's just a shot on the right. This is one of the fertilized plots, and on the left is one of our control. You can see it's greener, bigger plants, more robust growth. What we'd expect to see with plants that had more of the nitrogen fertilizer that they need.
Dale, you have a quick question. Derek is wondering if you can predict what the April 4th application would have looked like.
I think in 2019, at April 4th, we were probably not at green up yet. I didn't include a picture of our April 11th, what the grass looked like on April 11th, but it was really just waking up last year. So I think my guess is it probably would have looked a lot like the April 11th. I'm not sure. I don't remember well enough exactly what the soil and conditions were. We might have been just way too cold and wet. Probably even might have had some snow on there that first week of April last year. So these are our conclusions. One of the things I think we can say is that we got a response to that nitrogen no matter when we put it on. Even when we went so late that we didn't get a first cutting response, we got some in the second cutting. So again, I don't know that I would recommend waiting as late as the second week of May, but certainly into the first week of May, there's not a lot of penalty for putting the nitrogen on then. Definitely I think we can, thinking about this year, I think any time now that the field conditions are such that you can drive across the field without making too much of a mess, we could be putting nitrogen on starting now through the first week of May. And that, as I think we already knew, adding nitrogen is a good way to get a boost in yield for these grass hay fields. With good nitrogen management, applying some nitrogen and early cutting, I think that's the place where we can get some of our highest quality forages to use in our dairy rations are those early cut grass fields where we've got some nitrogen on to get the yield. Certainly is um, a tried and true practice, and I think we have some confidence now that even if you're getting to be a little late, it still can be worthwhile putting that nitrogen on. So,
Dale, I was going to jump
go
in
ahead.
and just mention that you may have seen we used ammonium sulfate, straight ammonium sulfate, which most of you that are applying nitrogen are not doing. You're using either urea or a blend of urea and ammonium sulfate. The reason we chose that product straight was because our plots are so small. Using the ammonium sulfate, which is 21% N versus the 46% N in urea, we have more product to apply, so we can do a better job of applying it evenly. I do feel, or we do feel, that there's a benefit to using ammonium sulfate, especially on fields that are getting limited or no manure. That, as many of you know, they've cleaned up the emissions now, so we're not getting the sulfur in the rain, and we're starting to see places where there's some sulfur deficiency. So I do believe where there's not a lot of manure applied, you know, bringing in maybe 30%, 25, 30% ammonium sulfate blended with the urea is worthwhile, and I think there's a response to it.
Okay. If you've got some other questions, please go ahead and put them in the chat box, and we'll catch up with them. We are going to switch over to our next topic now. I think we're almost on time. So I'm going to spend a few minutes and talking about some growing season issues with growing corn silage. Then April's going to jump in and talk about corn silage quality. And then this is really sort of a preface to Joe Lawrence's talk later this afternoon about hybrid selection, the Cornell corn silage variety trials, and things that he's learned that he can share with us on choosing varieties and variety performance. So really, to get started with this, you know, why did I want to talk about this today? And you know, I'll take sort of you know, I might say some things that make you bristle a little bit this morning, but I guess this is my I will say what I'm going after is maybe to make you feel a little uncomfortable, maybe make you question some of what we've been doing, and maybe there's some ways we can do better. So, you know, take it at that value, sort of starting with the 2019 crop year and weather. We know that 2019 was one of the most challenging years we've had for growing corn in a long time. We had a very wet start. We end up with late planting. We had a cool summer and an even more cool fall. We ended up with a lower number of growing degree day units than we've had in a long time. And we had a lot of challenges with corn silage quality. And I think we're also interested in having successful cover crops. We've seen that cover crops are definitely helpful for soil health. Growing soil health, improving soil health definitely is a factor in supporting good crop yields, you know, good drainage, you know, good fertility efficiency and nutrient cycling, all kinds of things that soil health helps us with. And also related to cover crops, we have at least a few people who are interested in that double crop forage that you can get with we get a good establishment of cover crop in the fall, we can end up with some really high quality forage and a decent yield if we can get a good stand and make that double crop work for our corn. And then the other thing, as we've been looking, silage quality. And April's going to talk a lot more about this. What's the starch content of our forages? Are we getting them to the finish line? Are we getting all the starch that we're looking for? And it's always this proper dry matter of silage makes a huge difference in how it keeps. Wet silage is a problem. We get poor fermentation, or if you're using an ag bag, you can't stuff it in the bag. And then especially once corn gets frozen, we can end up with very dry corn silage that also doesn't perform well in diets. Even if it's got the starch content, if the dry matter's really dry, it's hard to feed and get good performance. So here's a graph of the growing degree days or the heat units that we saw in 1999. I chose the location in Bloomville just because it's fairly central to where a lot of our corn's grown. And this dark green line is what was observed in 2019. This purplish line is the 30-year average, and this blue line is the 15-year average. So in the last 15 years, it's been warmer than the last 30 years. But we can see that 2019 was even below the 30-year average. So an atypical year for our growing season. So we're going to talk a few minutes about corn development. And so this is a typical way we talk about corn development as we come up through the vegetative stages. As the corn grows more leaves, we get to the reproductive stage here where we're at tasseling. And then as the grain starts filling, the ears start filling, we're going to be focusing on here sort of the soft dough and dent stage, sort of just from the point where those plants just start to dent till they're, we get to that half milk line, 32%, 34% dry matter, where we want to start harvesting silage. So this graph, if you look at it, is how the dry matter in the plant is accumulating. So as it gets bigger and bigger, we get more leaves, we have more dry matter. Then once we get to tasseling and the ear starts to fill, we're gaining yield. And then if we look at this section here between when we get to just about ready to dent through this, what I'm going to call stage R5.5, or when we get to that 32 to 34% dry matter, we can see that there's quite a bit of yield that we're gaining. The plants aren't getting bigger, but the ears are filling. And all the tons per acre that we're gaining through that time are all in starch. And so this is a big reason we're growing corn silage is for that grain content and the energy that's in that starch. So if we don't get it all the way to this stage, we're leaving some yield behind. So here's some data from Wisconsin that I was able to find. And if we look here on this dough dent and then to this 50% milk line kind of stage where we'd be typically harvesting we can see that the silage moisture content, 75 or 80, this is way too wet to be able to chop. This range, 70 to 75, you may be able to get that to N-sile if you chopped it, but it's still pretty wet. But here's really the stage where we're looking for that, getting above 30% dry matter. Up to 34, 35 is probably ideal. And then if we look here, what's the percentage of silage yield? So at the dough stage, we still have 25 to 35% of the yield that we haven't achieved yet. Even as we get here into the dent stage, until we get to this half milk line kind of range, we may still be 25% below what our yield potential is if we don't get it all the way to this half milk line 34% dry matter. And I think that's one of the things we struggle with. We know that when we do our corn dry down days, last year we did one the first week of October, and probably more than half of the samples, even in the first week of October, were not even at this 65% moisture. They were like at 25% dry matter, so like 75% moisture or more. So not even grain filling yet. So went back over the last 19 years of weather data and looked at the growing degree days that we accumulated between May 10th and September 20th. So this is a little bit arbitrary, I'll admit. May 10th is, it's not the earliest planting date, but it's not the latest planting date. So that's a pretty typical spot where we're shooting to have corn in the ground. And then September 20th, this is many years we have a frost by that date in some places. But it's also by September 20th, if we had the crop ready by September 20th, we would have the weather we need to get things harvested. We would have the opportunity to get a strong cover crop established. So again, those are the dates I chose. If you chose October 1st and September instead of September 20th, you'd have a few more growing degree days. But just looking at the data from Walton, down here is the relative maturity. So what this tells me is that 2 out of the last 19 years, we could have gotten a 100-day corn variety ripe by September 20th, planting on May 10th. 20% odds are not very strong. We can see that 10 out of those years, or a little more than half, we could have, something between 90 and 95 days would have gotten ripe. So when we talk about a full season corn variety in Walton, considering this date, maybe low 90s is a full season corn. But we also see we had 3 years of that time where a 90-day variety would not have gotten ripe on time. So what if we look at something from farther up the county? If we go to Bloomville, I also looked at growing degree days from Stanford, and basically it was about the same as this. So again, we can see where we have fewer growing degree days, where it's a little cooler. Here's 2, 3, 5, 6 years where something more than 85 days would have made it. But, a lot of years, maybe only an 80-day hybrid would be ready by September 20th. Now, you're going to say, I know we're growing, nobody's growing 80-day corn. Everybody's growing something in that 90 days range probably, and they're getting away with it. And part of the reason is it's never ready by the 20th of September. we're chopping well into October. Summers when we get, or falls when we get a nice October, that's great. When we get a miserable wet October like 2018 was, we all experienced how that went. So that's part of why I'm suggesting for our thought process here, at least, what if we wanted to get things ready by the 20th, so that we could have everything harvested before the 1st of October. Free up time for getting those cover crops in, and avoiding frosts and bad weather. And I think importantly, getting that crop to the finish line of actually getting a good starch content. So now I know that I've talked too long in this spot, and April's chomping at the bit to get going. So if you have a question, go ahead and put it in the chat box, but I will stop sharing and we'll let April jump in and share with us the silage quality data.
As Dale is transitioning there, a couple of points I wanted to note. One is that Dale went quickly through a slide, the map of New York State, that showed some colors briefly in the interest of time, and basically that showed what we might have all known, but perhaps we've lost sight of, and that is growing degree days in our area relative to other parts of the state. And it shows the cooler colors in blue, and a lot of Delaware County was yet in blue relative to other parts of the state. So just a reminder that we are cooler than other parts of the state. The other comment I'd like to make while we're in the transition of slide sets is that Dale has started the ball rolling about talking about starch and maturity, and for good reasons. And April's going to follow up on kind of what the cow implications, what we're seeing in Delaware County, and what the cow implications are for that. And it's also a yield implication too, and that's an important point here, is that when we are not getting these hybrids, no matter what day length they are, to the full potential for maturity, we're losing yield. And there's traditionally we've said 50% of the yield in a corn hybrid's in the grain. I think that still holds true. And so if we're not getting that starch laid down, we're not capturing that yield. And it has obviously not just a yield impact, but also a cow impact. I did want to mention that we also we have not talked about fiber digestibility, and that does not mean that fiber digestibility is unimportant. It actually is very important when it comes to all of our forages, not just corn silage, but it certainly does is a factor. We're focusing here today on the lay down of the starch, and its impact on yield, and also to remember how that impacts performance of the cow. So
There is a question here, Paul.
Yep.
How large of a difference do you feel between different varieties plant genetics for how starch develops in relation to the whole plant dry matter and maturity?
Okay, repeat that question again, please, Corinne.
Sure. How large of a difference do you feel there is between different varieties plant genetics for how starch develops in relation to the whole plant dry matter and maturity?
Okay, boy, not to punt on that, but I feel like Joe Lawrence, you're doing the hybrid trials, and Joe, you're on the meeting this morning. Would you like to unmute and take a stab at that answer, since you're looking at a variety of different hybrids?
Just a second, Paul. Corinne, I think you need to make April a co-host so she can share her slides.
Will do.
So I didn't quite hear the whole question, Paul. I apologize, but
Sure.
I can't answer it if we're waiting for the transition.
Just had you on mute.
Yep, somebody's got some feedback going on there. Derek would like to know, how large of a difference do you feel between different plant varieties and genetics for how starch develops in relation to the whole plant dry matter and maturity?
So actually, I have a couple slides on that for this afternoon. So maybe for the sake of time, I'll just address it when we get to those slides.
Sounds good.
Fair answer. Okay, we can see April's slides. And we'll just need to, I've got you unmuted, April, now.
Oh, good.
So we'll turn it over to you.
Okay. Hello, everyone. I'm I try to get to, I'm still in the shadow. I'm either all washed out on the video or shaded out too much. Anyhow, so we'll get started. So I appreciate having a chance to present a nutritionist point of view of the corn silage quality here in Delaware County. So when you get your forage analysis back, whether it's from Rock River Laboratories, just wanted to point out where to find the percent starch for corn silage. So on a dry matter basis, Rock River's analysis has it here at 32.86%. On a Dairy 1 forage analysis, down at the bottom, this one shows that it's 21.1% starch in this sample. And at Cumberland Valley on the left-hand lower corner, the one for this is 29.1% starch. I want to emphasize the importance of taking a good sample when you're sampling for a lab analysis. Just don't walk up to a pile someplace or a bunk and just grab a sample and shove it in a bag. Make sure that you're mindful when sampling, so you can take a representative sample for a good assessment. Take several hand samples and mix it together and take a subsample of that, and just be careful that what you're sampling is definitely what you're feeding the cows. So I want to talk about how starch contributes to milk production. What I did is I took a typical 40-pound inclusion rate of corn silage in a typical Delaware County diet and plugged it into the Cornell net carbohydrate and protein system modeling. And in this, for CNCPS, we call that, it predicts the metabolizable or allowable milk production for both energy and protein. On the protein side, starch does contribute to the growth of microorganisms, bacteria in the rumen, which the cow would later digest, and that impacts the amount of milk that's produced as well. That's why there's both energy and protein milk predicted pounds per day. So in one diet, we are looking at corn silage with a starch percent of 24%. And then we have a corn silage sample at 39% starch. Looking at the prediction of what the amount of milk that's going to be made with the 24% starch content for corn silage, on the energy basis, allowable milk, it's 64.3 pounds of milk with 58.6 pounds of milk on the protein side. With corn silage, with a 39% starch level, we have 68.3 pounds of milk. And on the protein side, it's allowing 63.9 pounds of milk. So if we kind of look at this, here's the milk pounds difference between those two. We're actually looking at 4 pounds less milk when you have a corn silage with 24% starch, it's included in the diet. So the more starch you have, the better off you are. And just so to give some sort of a reference, ideally you should have a 32% starch level in your corn silage or more. The more the better on this end. Okay, so now let's take a look at what's been happening in Delaware County for the last 4 years as far as starch content in corn silage. So this histogram has a number of samples represented on the left-hand side, and on the bottom, for instance, for this bar, there's a range for starch at 26.4% to 30.3% starch. So there's 24 samples in this column. This histogram represents 129 samples that were taken in 2016. The average for all these samples is 34.8. So what we did is we went ahead and we looked at starch percentages that are 31% and lower. So for 2016, we had 25% of all those samples with 31% or lower starch. In 2017, with that number of samples and the average at 31, we had 47% of the samples came in at 31% starch or less. Presumably because we had less growing degree day units. In 2018, we have 29% of the samples are lower than 31% starch. 2019, we have 42% of the samples with 31% starch. And I just want to point out, this was on 62 samples. We're still feeding 2019 samples or 2019 corn silage in Delaware County. So we haven't completed all the sample analysis yet for this depiction. Plus, this kind of represents what Dale was referring to when we've got 2019 did have lower growing degree day units for corn silage. So this last chart that I'm going to show here, this is a comparison of Delaware County to the Northeast corn silage analysis. And what we did was we pulled out information from the Cumberland Valley Northeast corn silage grouping, excuse me. And then we also added in Joe Lawrence's information on the Cornell corn hybrid variety trials. And we also have the precision feed management percent starch that came back on our analysis. And just to make sure that you understand that we really believe that these samples are pretty representative of Delaware County. These are the ones in the red. The reason why we incorporated the Cornell trial studies, just so you know that there was 2 sites in New York and 1 in Vermont. And these are the average starch levels for those varieties. And the Cornell trial, they are letting those corn silage plants or corn silage crop mature out. So these are the starch levels, and they're pretty consistent with what's happening as far as growing degree days are concerned. But this is getting that corn silage to peak crop production. So we can see here what's happening as far as trend. And of course, we mentioned 2017 and 2019 having low starch content. So the take home message that I want to kind of point out here is corn silage should be a major energy source for milk production by what it contributes for starch. Practice good sampling procedures when you're sampling your corn silage. There's a lot of work that gets done on doing a forage analysis forage analysis at the lab. It can be expensive. The time of what happens when you're sitting down as a nutritionist, modeling a diet to get the prediction to come out correctly and be able to present a prescribed diet out on the farm, it takes time, and we want to do a good job bringing that information out and placing the right feed on the farm. But it's very difficult when we don't have good samples. Plus, plant appropriate growing degree to unit corn for your farm to maximize the hybrid potential for yield per acre and the starch content. So I appreciate the time that you've given me. If you have any questions, please go ahead and put them in the chat box and we'll get them answered.
April, thank you. And can you back up a couple of slides to the last histogram that you shared?
Yeah.
Yeah. We spent a lot of time looking at this data and emphasizing the percentage of samples that were under 31% starch, what we'd kind of consider low starch corn silage. But I think it's well to note that there's a number of you out there in the county that are achieving high levels of starch in your corn silage. And every year, even on those cool years, 2019 being one, we've got farms that are managing to get their hybrids to physiological silage maturity and getting good starch levels. So it's all quite doable, I guess, is our point. And,
thanks, Paul, for bringing that. Whoops. Making that point.
And again, to emphasize, it's not that fiber digestibility is unimportant. It is very important, and it contributes a lot of energy to the diet when that fiber is more digestible. But that doesn't. I would say it's not either or. It's both. Getting both that crop to its physiological maturity for silage and having good digestibilities.